Hello, Dan Adilkowski here from howtomechatronics.com. In this tutorial, we will learn what capacitor is, how it works, and take a look at some basic application examples. There is almost no circuit which doesn't have a capacitor on it, and along with resistors and inductors, they are the basic passive components that we use in electronics. A capacitor is a device capable of storing energy in a form of electric charge. Compared to a same-size battery, a capacitor can store much smaller amount of energy, around 10,000 times smaller, but useful enough for so many circuit designs. A capacitor is constructed out of two metal plates, separated by an insulating material called dielectric. The plates are conductive and they are usually made of aluminum or other metals, while the dielectric can be made of any kind of insulating material, such as paper, glass, ceramic, or anything that obstructs the flow of the current. The capacitance of a capacitor, measured in farads, is directly proportional to the surface area of the two plates, as well as the permittivity of the dielectric, while the smaller the distance between the plates, the greater the capacitance. That being said, now let's take a look how a capacitor works. First, we can note that a metal typically has an equal amount of positively and negatively charged particles, which means it's electrically neutral. If we connect a power source or a battery to the metal plates of the capacitors, a current will try to flow, or the electrons from the plate connected to the positive lead of the battery will start moving to the plate connected to the negative lead of the battery. However, because of the dielectric between the plates, the electrons won't be able to pass through the capacitor, so they will start accumulating on the plate. After a certain number of electrons accumulated on the plate, the battery will have insufficient energy to push any new electrons to enter the plate because of the repulsion of those electrons which are already there. At this point, the capacitor is actually fully charged. The first plate has developed a net negative charge and the second plate has developed an equal net positive charge, creating an electric field with an attractive force between them, which holds the charge of the capacitor. Let's take a look how the dielectric can increase the capacitance of a capacitor. A dielectric contains molecules that are polar, which means that they can change their orientation based on the charges of the two plates. So, the molecules align themselves with the electric field in such a way enabling more electrons to be attracted to the negative plate, while repelling more electrons out of the positive plate. So, once the capacitor is fully charged, if we remove the battery, it will hold the electric charge for a long time, acting as energy storage. Now, if we shorten the two ends of the capacitor through a load, a current will start flowing through the load. The accumulated electrons from the first plate will start moving to the second plate until both plates become back again electrically neutral. So that's the basic working principle of a capacitor, and now let's take a look at some application examples.
The two metal plates are what we call a capacitor. Note: voltage is shown upside down in this video because the blue arrows will show electron flow. By briefly connecting the capacitor to a battery as shown, the two plates have developed equal and opposite charges. If we then connect the capacitor across the light bulb, all the extra electrons in the negatively charged plate will move to the positively charged plate through the light bulb. If we use multiple batteries in series, then we can force the two plates of the capacitor to develop larger amounts of charge. When the capacitor is charged, its voltage will be the sum of the voltages of all the batteries. Charging the capacitor to a higher voltage will cause the light bulb to stay on longer when the capacitor discharges. When a larger capacitor is connected to our battery, it'll take longer for the capacitor to charge to the voltage of the battery. Although the final voltage is still equal to the voltage of the battery, for a larger capacitor, this voltage represents a larger amount of charge on the two metal plates. The larger capacitor will take longer to discharge through the light bulb, thereby allowing the light bulb to stay on longer. This is by moving the two metal plates closer together. To create the largest capacitance possible, we want to make the areas of the plates as large as possible, insert the special material in between the plates, and move the two plates as close together as possible. The larger the capacitance, the more energy will be stored for the same amount of voltage. Much more information about electric circuits is available in the other videos on this channel. Please subscribe for notifications when new videos are ready.